I hope you all are doing good. The problem for today is detonate the maximum bombs. This is a medium problem in lead code. Just get started. The problem states that you have to return the maximum number of bombs that can be detonated if you're allowed to detonate only one bomb. Meaning the first in a you are given a 2D array, this, and the first index of this first index states the x coordinate, the y coordinate, and the radius of the, you can say, radius of the detonation. Basically its effects are basically felt in this whole radius. Okay. It basically the range of the, you can say, detonation. I'll just come here. If for example I blow the you can say blow the first bomb, blow the you can say blow the this bomb. It can basically, the range is 3, 1, 2, and 3. The range of this bomb is 3. Sorry, the range of this bomb is 3. If this bomb is blown, it basically it cannot detonate the, it cannot it cannot blow this the right bomb, because the this point does not lie in the radius of the, you can say, this point. But if we detonate this, if we first detonate the, if we first detonate the, you can say, right bomb, it can basically blow the left bomb, because the left point, this point lies in the radius of the, you can say, this, because it has the largest radius. This is also explained in the example. If we detonate the left bomb, the right bomb will not be affected, but if we detonate the right bomb, the both bombs will be detonated. So the answer is 2. The second question is here. If the answer will be 1, because if we detonate this bomb, only this bomb will go off, not this bomb. And same is the case with this bomb. Both bombs are independent of each other. Third example, basically, if for example, if we start from here, if we detonate this bomb, this bomb will trigger this bomb, because it lies in the radius of, you can say, the first zeroth point. The first bomb will explode. The second, on explosion of the first, you can say, first bomb, this will trigger the explosion of the second bomb, and a chain will be started. On explosion of the second bomb, the third bomb will be the third bomb will be exploded. Okay. And the explosion of the, you can say, yes, yeah, like this. The best bomb is to detonate bomb the best bomb to detonate bomb 0, because bomb 0 detonates bomb and 2, as I explained earlier, because these 2 points lie in the radius of the, you can say, zeroth bomb. The red circle, this is the circle of the, you can say, this is the radius of the range of the explosion of the first bomb. For example, bomb 0 will detonate bomb 1 and 3. The answer here will be 3. Then 3 bombs have now been have till up till now would have been exploded: bomb 0, bomb 1, and bomb 2. Bomb 2's explosion would trigger bomb 3, bomb 3's explosion, and bomb 3's explosion would trigger bomb 4. Therefore all the bombs are exploded. So 5 is the answer. Basically, the intuition behind, as you might have guessed, the intuition behind this problem is basically recognizing this as the graph problem, because there would be a chain of, you can say, basically chain. This bomb 0 will trigger bomb 1, bomb 2 will 0 and 2, bomb 2 will trigger bomb 3, bomb 3 will trigger bomb 4, like this. Basically, I think you can solve the problem. The graph problem is mostly, the graph can be solved using BFS, DFS, or DSU. DSU is a disjoint data set. But as you, there is one thing to remember here. This is a directed graph problem, not an undirected graph problem. Directed as such, because bomb 0 can, for example, bomb 0 can explode bomb 1, but the inverse might not be true. So this is a directed graph problem, and hence, if you are directed graph problem, you can't solve this using DSU. So there are only two choices: BFS and DFS. For example, the main thing to note here is how to check if one bomb can explode another bomb. The only thing that matters in this question is only this. For example, how do we know that I'll just bomb 0 cannot explode bomb 1, but bomb 1 can explode bomb 0. Hence this is a directly graph problem. But how will we check that bomb 0 can explode bomb 1? We can do this using a Pythagoras. For example, basically you can see this whole, this is a circle, and we have to check if this point lies in this bigger circle. For example, the point 61 lies in the circle with the center of 2 and 3, or say 2 and 1. The 2 and 1 are the coordinates of this circle, and 3 is the radius. 3 is the distance between 1, 2 and 3, and we have to check if this point lies in this circle. Use Pythagoras to measure the distance between your point and the center and see if it's lower than the radius. Calculate the distance between these 2 points and check if it's lower than the radius. The distance between these two points can be calculated easily using this x1 minus x2 of, and then square, plus y1 minus y2 and square. If this answer is less than the radius of the radius less than radius 3, then you can say this then you can easily say that this bomb then you can easily say that this point will lie in the radius of the first circle, and this bomb can explode the second bomb. There are 3 steps. Make a adjacency list, or you can say a graph, to check which bomb can explode another bomb. Run DFS on every bomb and check how many other bombs can it explode, and return the maximum answer. This is the whole, you can say, thing. I'll just start the coding. I hope you got my point. First we have to make the graph. I'll just initialize you can say adjacency list. Now we will use a nested loop to check how many how many bombs can that specific bomb can explode. I'll just skip, I'll just skip, you can say skip like this. I'll just skip the, you can say bomb. I'll just skip the duplicate bombs like this. If the I and j are same, you can just continue this loop. You can get the bomb, you can get the x1, y1 and r1 using bombs of I, like this. Bomb of j, this would be the second bomb, r2. Now if we will do a check, can detonate. We will pass 2 bombs. The first argument would be the circle. We are basically this would be the first bomb 1. You can say something like bombs of I and bombs of j. If for example, if this function would return a true or boolean, telling us that bomb I, that this bomb the first argument can explode, the first bomb can explode the second bomb. If this is the case, we will simply I would be the index of the first bomb. This can explode the jth bomb. Okay, this is the only required thing. Def. Now we'll complete this function. B1 and B2. You can say simply like distance something like this, x1 minus x2 square plus y1 minus y2 square, and we would simply return dist less than r1 square. This basically gives us the, you can say, adjacency list, and telling us one bomb can explain how many other bombs. I just showed you the result of the adjacency list. ADJ. Telling us that these the first index of the, you can, the first index can explode this bomb, but the first bomb cannot explode the second bomb, but the second bomb can explode the first bomb. I just something. Now we have built our you can say adjacency list. Now we can simply write a DFS function. This part is remaining. This would be our result for for idx and bomb in enumerate of bombs. We will simply return an answer. We will first initialize a set, and we will call the DFS function with idx and our scene set, and we will simply control counter is equal to maximum of counter and length of scene, and simply return this counter. Now the only thing remaining is to build this DFS function. I wrote this line because this set will contain all the all the components, all the, you can say, indexes of the bombs. That current this IDX can explode, meaning that I'll just write the function and explain again. DFS node scene dot. This is the same standard template for writing a DFS function. There are only four lines required to write a DFS function. All just run. accepted. Now I'll explain again. First you have to build a list that explain that returns you the returns you that how one bomb can explode how many other bombs. For example, 0 can explode 1 and 2, and 2 can explode 3, 3 can explode 4. Basically this returns you you can say just as a list. And you have to only add 0 can how will you know that 0 can explode 1 using this formula. You can easily read more about this formula on the you can say internet. Basically you have to check that if you have to basically check user to measure the distance between your point and the center, and if it's lower than the radius. I have done the simpler thing here. Then basically you have to basically run DFS on every bomb and check how many other bombs can it explode, and can it explode here, like here. And it would run DFS. It would run DFS on every of other. For example, first DFS would be first you can first the first index here. Then for example we will check how many other bombs can this bomb explode. Same here. And we will this set would contain all the bombs that are current bomb explode, because we are adding the bomb here, scene dot add set. Then we will this is the maximum counter we have gotten up till now. This length would the scenes set to length would be the number of the current bombs that can explode that can explode it, and we would simply return this answer here. I hope you got my point. Thank you for watching the video. Please like and subscribe.